Let's look at a few other things we can do with our sum and difference identities for sine. As an example of what we can do, let's take a look at the following expression. We have sine of 7 degrees times cosine of 38 degrees plus cosine of 7 degrees times sine of 38 degrees. And we don't know off the top of our heads without a calculator what sine of 7 degrees or cosine of 38 degrees are. Those are not standard angles on our unit circle. But nonetheless, we can actually compute this and compute it exactly without having to use a calculator by recognizing that this is the pattern for the sum of two angles for sine. And the way to notice that is that we have 7 degrees appearing twice. We have here, and if let's call that alpha so it matches the pattern that we have for sine of alpha plus beta. So alpha appears twice, and 38 degrees, let's call that beta, that appears twice. So if we recognize our pattern, this is exactly sine of alpha plus beta. So we can simply rewrite this now as sine of alpha plus beta, where alpha is 7 and beta is 38 degrees. And with that, we can just replace what alpha and beta are. That's sine of 7 degrees plus 38 degrees, which is sine of 45 degrees and 45 degrees is an angle that we know. Sine of 45 degrees is the square root of 2 over 2. So we were able to simplify this rather messy looking expression just by using the fact that it follows the pattern for sine of the sum of two angles. Now let's look at another example. We're going to simplify sine of 33 degrees times cosine of 3 degrees minus cosine of 33 degrees times sine of 3 degrees. Well, this is a similar pattern to the one we just saw, where we see 33 degrees appearing twice. We see 3 degrees appearing twice, right? It's sine cosine minus cosine sine. That is the pattern for the difference of two angles. It's sine of the difference of two angles. So if we give these labels, we call 33 degrees our alpha and 3 degrees our beta, then we see that this is sine of alpha cos of beta minus cos of alpha sine of beta. And that is the formula for sine of alpha minus beta. So in this case, our alpha being 33 degrees and our beta being 3 degrees, we can simplify this. So 33 degrees minus 3 degrees within our sine, and that simplifies to sine of 30 degrees, which we know to be 1/2. So that is how that rather messy looking expression simplifies. Now, in addition to computing exact values of certain expressions, we can also use the sum and difference identities to prove various identities or to simplify certain expressions. So as an example, let's try to simplify sine of pi over 2 minus x. This is going to be what's known as the cofunction identity. And you may have already seen that, and you may see it in the future, but it's nice to see that one tool that we have can be used to prove another. So let's see what sine of pi over 2 minus x is by using our difference identity for sine. So according to our difference identity, we take sine of the first angle times cosine of the second angle. In this case, it's just x. And then we subtract cosine of the first angle, cosine of pi over 2 in this case, times sine of the second angle. which is x. And now, cosine of x, we don't know what x is, but we do know what sine of pi over 2 or cosine of pi over 2 is. So that allows us to simplify this a little bit more. So let's remember, sine of pi over 2, that's at the point 0, 1, and that's where sine is 1. So this is 1. Cosine of x just stays. Cosine of pi over 2, well again, we're at 0, 1, that's where cosine is 0. So the cosine of pi over 2 is 0. And so this whole term goes away, it's 0. And so we're left with just 1 times cosine of x. We just get cosine of x. That's all we're left with on the right side. So that proves what's called the cofunction identity for sine and cosine. And again, you'll see that later, or maybe you've already seen it, but it's a useful identity, and we've just verified it. Okay, let's do one more. We're going to simplify sine of x plus pi over 2. And again, we can just use our addition formula, our sum formula for sine. So we just expand, we take sine of the first angle, so sine of x, times cosine of the second angle, so cosine of pi over 2. And we add cosine of the first angle, so cosine of x, times sine of the second angle, so sine of pi over 2. And now we just have to simplify using values that we know. So let's see. Well, sine of x, that just stays. But cosine of pi over 2, remember that's 0. We saw that previously. Cosine of x just stays. But sine of pi over 2, that is 1. So that simplifies to 1. And so what we see is this whole term goes away because it's multiplied by 0. And we're left with just cosine of x. So we see that sine of x plus pi over 2 is just cosine of x. And we've just verified this identity using our sum formula for sine.